Okay. I'd like to start the next panel, which basically follow up on the important panel that we just finished. Thank you for Murad and the panelists for a very interesting panel. If there's no chatbots, there is no agentic AI if you don't have the infrastructure for AI. And this panel is going to touch upon this very well, hopefully. And it's moderated by a dear friend of mine, Edgar Masri, a veteran of the industry, a hardware person like me. Thank you. And then, of course, amazing panelists. You'll hear from them in basically in many areas of infrastructure, from silicon and networking. So I'll leave it to you, Edgar. Thank you.
Thank you, Walid. Thank you, Abdul. Thank you, Fadlo. And thank you all for being here. I'm very honored to be moderating this panel. I did not graduate from the AUB, but by osmosis, I'm a very, very close friend. AUB, know a lot of people like Jack Merib, who's one of the trustees, but most importantly, Abdul Khadifa, who's a classmate, and then after that, a housemate. So we can share a lot of stories afterwards if you want. Good. I am currently CEO of Liqid. It's a startup that optimizes the usage of GPUs, but also memory, specifically on-prem. We're going to talk about that because the earlier panel talked about what could happen in the MENA. But before that, I was CEO of Acton in Taiwan. It's a public company that actually powers half of one big hyperscaler and then 20 to 15% of others. So I'm very, very familiar with the cloud aspect of things, but also the on-prem solution. And before that, I was CEO of 3Com. So networking is near and dear to my heart. I graduated from École Centrale in France and then came here to the US went to UC Berkeley, and then 6 years later decided to go to the business school here at Stanford, and I'm very excited to be here and leading this panel. I would like to introduce, in this order, Hani Daou, who is a Lebanese engineer and business development executive based here in San Jose, California. After graduating from the University of California in San Diego, he held roles in optical network development with Silicon Valley titans like Intel and Apple. But the main and exciting thing about Hani is that he has since rejoined MultiLane, which is a high-speed testing vendor anchored in Lebanon. We're going to talk a lot about MultiLane because it's a great example of how we could learn from what MultiLane is doing and then replicate it. And he's here with us because his father, the founder of the company, is in Lebanon, and it was very important at this stage to stay with the employees there. So thank you, Hani, for joining us. And I would like to introduce Mohamed Fawzy, who I had the pleasure to meet recently, who's a senior director of engineering at Nvidia, where he leads large, high-impact teams building and operating AI platforms at scale. We talked a little bit about GeForce, with deep experience across AI infrastructure, cloud platforms, and large-scale distributed systems. He focuses on turning complex technology into reliable production-grade execution. So thank you, Mohamed, for joining us. And then we have Jumana Muwafi, who is BE Electrical Engineering in '87 from AUB, and she's Senior Vice President at Synopsys, where the CEO is also Lebanese, so we're very, very lucky with that. And she leads the global teams developing and supporting IP cores for chip designs in mobile, high-performance computing, and automotive industries. And then last but not least, Wael Noureddine, BE Computer and Communication Engineering in 1996 from AUB. He's Vice President of Silicon and Architecture at Microsoft, working on next-generation infrastructure for Azure Cloud and AI. Wael graduated from AUB with a BE degree in Computer Communication Engineering in '96, as I said, and then joined Stanford, where he earned an MS and a PhD in electrical engineering, specializing in computer architecture and networking. So with this, I'm going to turn it quickly to Team C if you want to add anything about your background or MultiLane before we delve into the key topics.
Sure. So it's great to be here, guys, and Thanks for the opportunity to talk about what we're doing here in Lebanon. MultiLane was founded on a dream of corporate social responsibility, not only to develop high-speed test equipment and connectivity for networking AI clusters, but also to do it out of Lebanon and to be one step towards proof that AI infrastructure can be developed out of Lebanon. So I'm sure we'll get into details on that very soon.
Great. One quick word about MultiLane. I was still recently, before it was acquired by Keysight, on the board of Spirent, one of the leading testing firms, and we held high regards for what MultiLane has been able to achieve. And I was lucky to be invited by Fadi, the founder, to visit and see not only what a company is capable of doing in terms of hardware in Lebanon, but also to sell it to top-tier firms worldwide, but also attract amazing talent. And we're going to talk a lot about this because I think it's an example that not only we could, but we should be able to emulate. Turn quickly to Mohamed, if you could just say a few words about what you do and then how it's relevant to this discussion.
Well, thank you so much, first of all, for inviting me. I'm a friend of AUB. So I'm actually Egyptian, so I feel like I'm in my extended family here with my fellow Lebanese.
Thank you.
So thank you so much for inviting me today. I work in Nvidia. I support basically the GPU infrastructure that powers researchers in Nvidia. A lot of people, I actually didn't know before joining Nvidia that it had a significant research team. So Nvidia had a lot of researchers across the board, self-driving cars, LLM models, it's a lot of research, medical, biomedical. So all these researchers need, of course, GPUs to experiment and advance the state of the art. I run the 80% of the internal GPUs in NVIDIA, which is a significant number. And I focus on building the infrastructure, the AI platforms specifically, that enable researchers to move at the speed of light. And moving at the speed of light is a term we use in NVIDIA. Nobody can move at the speed of light, of course, but it just indicates that we try to remove as much bottleneck as we can in order to make them productive. So I'm here to, first of all, thank you for inviting me again. And hopefully I can share some of the insights about how to run large-scale infrastructure and the complexity around it, and how can we apply this to the region and benefit of Lebanon as well.
Good. Thank you, Mohamed. Jumana?
Yeah, so Jumana Muwafi, I work for Synopsys in IP development, and a little bit about IP, which is it's silicon IP that's building blocks of the chips that go into different applications for different market segments, whether it's in mobile, consumer products, automotive, or high-performance compute, which is the chips that are in the data centers. I think for today, the focus is more on the high-performance compute and the infrastructure buildup to power AI. And that's where, the biggest growing market that we're working in. So we do develop these building blocks to enable the connectivity of the chips, connectivity to memory and connectivity between the chips to each other. That's the part that I work in. And then, at a more larger scale in Synopsys, we have also the tools, the EDA tools that enable these chip designs to happen, as well as the multi-physics simulation and analysis, which are becoming part of the kind of high problem statements in the data centers, which we'll talk about today.
Thank you, Jumana.
Yeah, thanks, Edgar. So before Microsoft, actually, I was part of a startup with a very big vision. We actually thought about next generation infrastructure for data centers. We built the whole stack from silicon. We designed chips, we built the chips, we built systems around the chips, software. We had the whole kind of architecture of the data center. And all of that, then Microsoft acquired us, and then suddenly ChatGPT kind of burst into the scene. And then what we're seeing now is really unprecedented. I think everybody here knows what AI is today. There's nobody who hasn't actually seen something come out of AI, whether it's videos or good and bad today, especially with the war. But for us, who have been working on infrastructure for a long time, this is really unprecedented growth. What we're seeing today, and I think maybe we'll touch on some of it, is really unusual. I see a lot of people trying to kind of make sense of it, try to draw a parallel to prior revolutions, like whether it's the Industrial Revolution, or some people think of the printing press as, hey, this is an example of what's happening. And really, it doesn't even compare. I mean, printing press was very impactful, but it had almost zero impact on or demand from infrastructure. People would just print, carry the books in carts, and that's it. People would just read them. Even Industrial Revolution, as important as it was, is not comparable to what we experience today. You could start a car company in your garage. You can start a plane company in your garage. But today, you're not going to start a training cluster in your garage. That's completely prohibitive. And I think looking especially today, what's happening is there's incredibly concentrated spend from very few small entities that can actually do it. And there is a reason for that. It's not just because some companies are doing great, getting a lot of good margins, but it's because the problem itself has inherent demands. And these demands from the infrastructure perspective, again, go across. They go from all the way from kind of the foundation, the civil engineering part of it, how you build the data center, how you cool the data center, how you power the data center. Incredible demands, and they're straining even the biggest companies. Being inside Microsoft, I can see that this is beyond actually what experienced people have done in their life. So there's definitely a very fundamental change today in infrastructure. I think it's good to know what's happening. I think maybe we'll talk about it a little bit from kind of trying to be part of it or replicate some of this will require, I think, kind of government, I think at least in the Middle East, participation is not something that individuals can get into. But it is obviously critical because we are seeing what AI can do from a security perspective and a general sovereignty perspective. It's critical. It's good to see that quite a lot of people from the region are actually involved. I can see that. There's a lot of expertise, so hopefully we can also help build that back at home. So I think one thing I wanted to note is some of the slides we're going to show are from Microsoft, but I'm not representing Microsoft here, I'm representing myself, and the folks who created them were gracious enough to share them. They are public, so there's nothing proprietary here, but it's information that came from a Microsoft presentation.
Yeah. Thank you, Wael. I mean, there's one key theme I want to highlight here is how you take something that is now actually owned very much by the big hyperscalers. I mean, the statistics keep moving because things are changing literally by the month. But 45 to 50% of the GPUs are bought by the 4 hyperscalers. It will change, but still, this is a major concentration. The next 25% is owned by second tier or bought by second tier firms. And when I say second tier, that's Apple, that's Tesla. So these are very large companies. So we're talking now 3/4 of the GPUs being consumed by these big firms. And then now let's start getting to the enterprise, whether it's the banks or whatever. It's a small percentage. So what does it mean? It's for the Nvidias, for the AMDs, et cetera, who do you focus on? And yet, when you look at the challenges, for whether it's in the Middle East or even when and I go to Japan or Asia, real estate is an issue, cost is an issue, in being able to do this, build an infrastructure for security reason, for governance, for just the ability of autonomy, especially in a very fragile geopolitical world. You need to do something. And this is what we're going to touch on here and show you there are ways to do it. And there are actually ways for the MENA region in general and Lebanon to not only benefit from it, but lead the charge. I'm going to try and first just describe very quickly what we mean by AI infrastructure. Yesterday, when I was talking to people, he said, first thing is like, well, what do you mean by infrastructure? And again, thanks to Wael, we have a very, very basic slide that shows where infrastructure sits, which is really at the bottom. It's the basement. It is the structure upon which you're going to build your whole system. And then it's broken down into multiple layers. So, Wael, if you could say a few words on this, and others could talk to it.
Right. So I kind of mentioned a little bit of what's actually involved in or the kind of problems people are trying to solve today to build these gigantic data centers. What some people are calling AI factories, or concentrated, mostly GPU power in one area. So and the observation, looking at all of the large companies today, is that they're all, very frantically are active, solving a lot of problems across a lot of these layers. For instance, look at networking is one. You'll see that not only is let's say the equipment needs to be faster, but also the protocols themselves are inadequate today. They have to invent new protocols. They have to invent new ways of cabling, new fiber technology, new switches, new NICs. I mean, there's a whole kind of overhaul of the network within a data center. The topology of the network is different. So, and this replicates across all of these different areas. Power is another example. How do you power a rack that is almost like a megawatt? So think of it this. You went from what used to be like 4 or 5 years ago, people would say, 20 kilowatts is what you have. Can't go above that. Actually, it's an observation. Every single thing that we used to hear as, this is our limit, 40 megawatt is the largest data center we can build. Now we're talking about 2-3 gigawatts. What Lebanon consumes is 2-3 gigawatts in one data center, the size of a village square. So that the kind of the barriers that people had put around things or from themselves suddenly disappeared because the incentive is so large. And it's also a lesson, I think, for other areas is to not always follow what people say or think that this is a limit that somebody thinks is there, because one day it just disappears and people are doing things way beyond what they thought was possible. Cooling, clearly when you're consuming a lot of power, you have to also take that power out of the system, and cooling solutions are very challenging. There is a lot of, obviously, need for going to liquid cooling, but there's a lot of equipment that's not liquid cooled, so we can talk about how people are solving this today. There's quite a lot of investment, and people are willing to pay for solutions that look complicated, but they are necessary to make this whole thing happen. And again, silicon, we all, a lot of us have worked on silicon before, realized that, of course, doing silicon has become more and more expensive, and this is adding to the fact now that only a few companies can actually build these things, and only a few companies can actually build the silicon for them. So the barrier to entry from somebody who just wants to build a data center is just going way high. And I think, again, thinking back to how could we do something back at home, I think there's a lot of work and a lot of, again, active government participation for this to be actually possible. And so the last thing is, we shouldn't ignore what it takes to construct a data center. And I'm not a civil engineer, but I was, as part of trying to put our equipment in a data center, you realize there are a lot of problems to solve even within kind of architecture and construction of the data center. And that expertise is something that, again, is getting also localized into just a few entities in the world. So I think all of us involved in some way or another in this AI revolution are starting to realize that the concentration of the knowledge is going towards maybe two countries. And within those countries, maybe a handful of entities. And unlike anything that has happened before, there's one other aspect of what's going on today that is different from prior revolutions, is that it's not open to everybody. Now, yes, you can use it. You can use it as much as you want. You can build applications. You can do all of that. But kind of building it is very hard. So that's not, maybe it's not a very rosy conclusion, but I think if we go over some of what we're all working on, I think you'll get a sense. And I think with what's clear is even in the US, with enough funding, you can make things happen. So I think that's what's missing to get this done elsewhere.
Great. Thank you, Al. So looking at the stack, I want to turn first to Jumana and then Hani. Where does Synopsys play in how things have changed over the past 3 years, given the demand for AI infrastructure?
Yeah, so if we look at the silicon, which is one of the levels of the stack, and we're looking at some of the previously being system companies, the hyperscalers, are all going vertical integration and building custom silicon for their data centers, because the problems that Wael talked about need to be solved at every level of this infrastructure stack, including the silicon. So it's getting the silicon to be faster. It's all about faster access to data, higher bandwidth and capacity for this data. And to solve these problems with the megawatt rack or the gigawatt data center, it's all about compute density that you need to put. But with compute density, then how do you power it? How do you dissipate the thermal energy that is created by this power with the density of the compute? And that's where it gets into the new solutions, which is stacking. The memory is being stacked in 3D, so you cannot go 2D. There's just not enough space to go 2D, so you have to go 3D stacking. So the memory is getting 3D stacked. The silicon is getting 3D stacked, which then exacerbates also the thermal energy problems that need to be solved, because with 3D stacking, how do you dissipate, how do you cool? That's kind of your domain, Edgar, with the liquid cooling and et cetera. But then also the connectivity within the data center. Things are exceeding the limits of the copper connectivity, and that's where optics are coming into the picture. Optics even are coming and being co-packaged with the silicon in order to make it faster, lower latency. It's all about access, real-time access to the data very quickly. So it's quickly turning into the connection between the silicon problems that are being solved are very much connected to the physical problems of the data center that need to be solved, from power, from interconnects and thermal. So that's a major shift that we're dealing with. The tools have to catch up to solving these problems, whether it's low power design, smaller area, the simulation and analysis of the thermal aspects. The thermal aspects also end up having an impact on the structural integrity of the silicon and the packaging, so the mechanical aspects of it. So that's where we're seeing a lot of the shift right now in terms of connection to the problems that need to be solved for the data centers.
Yeah. Thank you, Jumana. I'm going to turn to Hadi, but Jumana made a couple important points. First, about optical becoming very important. And I think it was last week or the week before, OFC where, which is a traditional show on optical, it's getting more and more attention just because people feel like they cannot go to optical, electrical, and then have to go all the way optical. We work with a very, very large Japanese service provider, and they've determined that in a lot of areas they just have to go all optical. And so with this, I want to turn to Hani, where MultiLane actually is a pioneer in testing and therefore being ahead of the curve on what's going to be deployed. Tell us a few words about MultiLane in this, specifically this domain and more generally.
Sure. So you guys see that little slice on the bottom of the diagram that says infrastructure. When OpenAI first released ChatGPT a number of years back, the total addressable market of that slice was about $250 billion. Today, in 2026, it is trending towards 1.5 trillion. Now, that's a very exciting number, but to deliver that number, everybody on this stage here is being asked to reinvent themselves and reinvent their products and their value propositions every 12 to 18 months. Another example is 6 years ago, the bandwidth of the cable that connects a GPU to a switch was 100 gigabits per second. Today, that same cable, which is shipping today, has 1.6 terabits of bandwidth. So in a matter of 7 years, we went 16x in the bandwidth there. MultiLane's focus is testing the high-density connectivity between these GPUs and between the different components of the network. Testing has become a central focus towards being able to deploy these GPUs at scale. We have no way back. We can only go forward to be able to pack more and more connectivity in these racks and pack more and more of these racks together. We have to keep going forward because we need to reach a tangible ROI for this incredible scale of CapEx that everybody's putting into the market here. One example I like to start with MultiLane is there's something that Nvidia, Amazon, Meta, Microsoft all have in common. All of them would be delayed in their infrastructure deployments if MultiLane wasn't able to deliver the products that we ship every single week out of Lebanon. We make little pluggable modules to test GPU ports. We make large test systems that get deployed in contract manufacturers to test the cable mesh networks between GPUs. And now we are also venturing into making the connectivity itself, which connects GPUs together and GPUs to switches. So we, the physical layer side, it was kind of the unsung hero of the whole game, but now we're front and center again because these technology refreshes are happening every year and a half. You might deploy a complete system, it'll cost you maybe a couple $100 billion, and it will be rendered obsolete in a matter of 2 years. It's because we are constantly being forced to push the boundary of how many watts we can fit into a chip and how many connections we can fit between these chips in a single rack. So the name of the game is cost effectiveness, test coverage, and out of MultiLane, we've found that we can play to our strengths and we can play to the strengths of the Lebanese people. It's not our game to go build at the speed of capital like our partners in the GCC are doing. What Lebanon can do in this sector is really to focus on the value niches, both in the infrastructure stack as well as the application layer, where we can leverage the talents we have and leverage our global positioning to be able to develop the nation as much as we can.
Great. Thank you, Hani. And it's great that you mentioned this whole aspect of testing. And just anecdotally, we're working with a very large service provider here in the U.S., and they started with the H100 of Nvidia, 450 watt or so, and then in coordination with Nvidia, they determined that they needed the H200, which is 600 watt. So guess what? Now all the testing has to be restarted. Maybe not the full year and a half, but they needed accelerated testing to be able to test something with 600 watt. Just moving 25%. Required a major testing repurposing. And this is where companies like MultiLane play an important role because they're bringing something that can accelerate the testing. And so I don't think Hani was bragging too much when he was saying that these 4 hyperscalers depend a lot on testing equipment, whether from other firms like Keysight, Viavi, or also MultiLane. On this point, if you could say a couple words, Mohamed, on this way where Jensen Huang said, every year I'm going to get you a new GPU, and you better be ready for it.
Yes, yes. So just a quick question first, with a show of hand, really quick. How many people here are non-engineering background? Okay. It's more than I expected. All right, so let me try to simplify it a little bit. So first of all, I really like the analogy of the AI factory. What are we building here? Like, what are these factories? So when you think about a traditional factory, like a car manufacturing, for example, right? It consumes raw materials, right? Iron, and produces something useful, car that you can drive, right? So what does this AI factory does? What does it consume? What does it produce? So it consumes tokens, like data that you produce, actually.
Money.
Right? And it's supposed to produce, guess what? All tokens, more tokens. So this is like a very interesting factory. It consumes the same thing that it produces. So what is the value? Right? So the value is the intelligence it will produce, because what it produces is more intelligent tokens than what it consumes. So I'll give you a very simple example. And this is real. So I bought the ChatGPT subscription for $20. I think this is the best $20 I invested ever in my life over the past 3 months. Because I used ChatGPT last quarter to invest in the stock market. So I used it as my financial advisor, okay? So it's $20. I've never seen such a return in my life, because it wasn't 10x, it wasn't 100x, it wasn't even 1,000x, it wasn't even a 10,000x. So it's a lot more, right? So how? I generated tokens, dumb tokens, right? Hey, tell me what is the best AI infrastructure company that I can invest in that is on the critical path of interconnect, right? Walk me the chain of manufacturing, right? And the AI infrastructure build out, and show me which company is positioned better. This is real dumb tokens, right? And then it produces smarter tokens. So like, oh, here it is. Okay, tell me why you chose that. Here's why. I want you to challenge yourself. Oh, here's why, right? So this all is powered by a factory somewhere, right? An AI factory that is using all this amazing technology, right, in order to produce this smarter tokens, right? Now, I hope that ChatGPT doesn't increase their subscription, right? But from like right? Is this recorded? So, from like these factories, what are they benefiting? Well, they want to optimize the ROI. So they spend billions of dollars in building these factories, right? So how do I optimize the ROI? I want to optimize the manufacturing process inside this factory, right? So how do I optimize the manufacturing process? How do I increase, right, my ROI? Or how do I reduce the dollars spent as a manufacturer per token? So every token I produce, I want to spend as little as possible in terms of dollars. So this means I need to optimize my factory, really, really optimize my factory, right? So this is where the AI platforms comes in, right? So AI platforms' role is to optimize this factory. How do I squeeze every single cent, right? Penny even, out of my factory in order to improve my ROI, right? Now, I used to work for Meta before it became Meta. It's like it used to be called Facebook. In 2016, the size of this factory was like we were training models on 1,000 GPU. When 2016, we trained the model on 1,000 GPU. We're very happy about it. We published a paper and it was like, oh my goodness, this is a breakthrough. Okay. 10 years later, the factory, an average factory is like 50,000, 100,000 GPU. A decent factory is 1 million GPU. 1 million. That's 1,000x complexity or 1,000x scale in 10 years. I'm not aware of anything that scales 1,000x in 10 years, right? So, and this scale, like, stresses everything out, from material science to chip design to cooling to infrastructure to connectors to software. Like, how do I manage a factory that is now 1,000 times bigger? How do I make it more efficient? How do I make it more optimized, right? So my role in Nvidia is to try to solve this problem for the AI platform, right? And I think it requires a lot of talent, actually. Like, and I think this is what the region can offer, like ML optimization, ML ops, ML operations. Like, surprisingly, we it's actually hard to use AI to solve this problem, but we're trying to use AI itself to help us optimize itself, as how do we run these factories. Yeah.
Thank you very much. So Mohamed just touched on the very high end, where we're talking million of GPUs, but for what we want to start in the Middle East, or what even universities, we work a lot with Texas A&M. In AUBs, I heard just considering a GPU cluster, we're talking 15, 20, maybe even 5 to start with. One thing I wanted to touch on, just to put some context, is some just basic terminology, even for those who are not technical, to understand how the whole concept of building a cluster happens. So first you have the scale up. So think of scale up as the vertical setting up. It's just in one rack. Then the scale out is when you start connecting multiple racks. And then here it says AI WAN, but familiarly people say scale across. This is how you get to the millions. And so I want to turn maybe quickly to you, Wael, and then Mohamed, to just give a quick example of what the scale up, scale out, and then scale across, or AI WAN as a concept.
Yeah, I mean, it all started with really scale up, right? Scale up meaning you build one machine that has multiple GPUs in it, and that's what Nvidia started a while ago with these DGX systems, or a handful, 8, maybe 16 GPUs, and that's not that long ago, actually. But it quickly became obvious that you need more, right? Especially with LLMs, and people try to now connect these machines together. Problem turns out, as I mentioned earlier, the network wasn't actually ready. Like, whatever people were deploying wasn't good enough to scale these racks across the data center. And so what this slide actually is mentioning at the bottom is a couple of industry efforts to build new generation networks for AI, for both actually scaling in the rack itself. Scale up today is dominated by proprietary solutions. So every GPU vendor came up with their own way to do it. Now some are trying to build maybe kind of a more standard solution, which allows building more interesting racks than just GPUs built by one vendor. But also going across the whole data center, how do you take, for instance, if you're talking about 100,000 or up to 1 million GPUs, we're talking about tens of thousands to 100,000 racks. And that problem by itself, if you've done networking, if that's something that you've looked at some point in time, is orders of magnitude larger than what people have ever tried to build. So conceptually, you can maybe draw a topology where you're connecting all of these things together, but actually physically implementing it is a lot harder. There is as we were mentioning earlier, there's technology that is needed, fiber, to be able to get to the reach where you can build that topology. Copper doesn't go far enough. Existing optical solutions are very power hungry, so there's quite a lot of obstacles to really implement. And people have been solving them over time, but there's still a lot of work to do to get there. So from a networking perspective, there's been a frenzy of activity in the past 3-4 years with new protocols coming up, new technology coming up. There are some ideas that maybe 10 years ago people would, which we implemented actually in our company. We had people who had intense focus on networking. And one idea, for instance, is from a source to spray the packets across all the links. So like the packets just go out of order, arrive to the destination out of order. And people would kind of dismiss it outright. When you describe it, we're not interested. We know how to do it, there's no problem. Today, this is the standard way of doing things. The shift has been unbelievable. People just realize it's actually necessary, and because the application was worth it, they just did it. So there are examples like this everywhere, as I mentioned. You see obstacles that people have placed for years just disappear overnight because now we need to do it, we're going to do it. And it's exciting, actually. There's a lot of opportunity today. If you're in this space, there's a lot of opportunity to build new technology, to try to build components that solve these problems. And it's, I think, a unique time that we need to take advantage of. So now, even kind of one data center is not sufficient. And people have started to think, how can I connect multiple data centers to run these giant models? Hopefully that will be solved. I mean, I hear interesting ideas come up about smaller models, but for now, that's what people are trying to do. They're trying to go even beyond one data center, do the training across. That is another problem. Just impossible today to run things with the existing protocols that people have been running forever in a satisfactory way. So a lot of work has gone over on that as well. So I think in the next couple of years, we're going to end up with something completely different. It was already pretty different at this point. And I think it will go back and feed into the general cloud and other use cases. So the technology in general that's being developed here with all this funding will be beneficial across all the applications.
Thank you, Wael. I don't know if you want to say any words. I want to touch a little bit on the scale across and then turn to Hani. So even if you're talking about a small number of GPUs, thermal is a problem that was mentioned earlier to the first panel and then today. And so a simple way of describing it is one of our partners in Japan, they want to have the GPUs in Hokkaido where it's cold and then connect them to the data center with the memory in Tokyo, just primarily to reduce the bill. And so that calls for a scale across, because now you're talking, hundreds, not more kilometers. I'm going to turn to first Hani, but then others to talk about what is becoming available. So if in Lebanon you want to have, the AUB wants to have something at the AUB campus in Beirut, but then maybe have in Faraya some of the GPUs to reduce the bill. Is this happening? And if so, what would it take?
So I'll use the copper versus optical analogy to respond to this. So today, GPUs are connected to each other largely over copper connectors. If you look at the scale up on the far left, just the copper connectors and the plastic molds which go into connecting all these chips together, the total addressable market just for that component alone in 2026 is 12 billion. But we are trending towards use cases like what you're describing, where compute needs to be disaggregated across larger physical space to be able to take a bit of pressure off of the real estate component, the power consumption per unit area component as well. So what we're seeing in the industry is a shift from connecting GPUs together over just copper to connecting them over optical, using lasers, using transceivers, using drivers. Today it's still challenging due to some technical disciplines like, lasers they blink, if you will, and if you blink while you're doing a computation, then you have to start over your computation, so that's why everybody went to copper. But then really the world is actually running out of copper, and these physical racks by themselves, they're so heavy that a lot of data centers today, they have to reinforce the flooring and completely rebuild how they pour in cement and steel into foundations to be able to sustain the weight of this infrastructure. So to use your example, one trend that we're seeing in the industry, and Jumana, you also pointed to it, is integrating the optics into the GPUs and integrating the photonic fabric, if you will, that can not only connect GPUs across a very condensed unit area, but spread it across campuses and maybe all the way to Faraya and soon enough.
Great. Well, thank you. Other comments from Mohamed or Jumana on that
Yeah,
architecture?
just touching on the previous points, I mean, the speed at which the data rates is happening is just unprecedented, just to reinforce that point. So what we see with the connections that are required, when we talk about scale up or scale out, we're really talking about connecting GPUs to GPUs, CPUs to CPUs, and then together, to connect. And the data rates, I mean, what we've seen in the past, the standards and the protocols maybe take every 4 to 5 years, they kind of move to the next level of the data rate. The data rates for memory, the same thing. Now we're actually seeing the demand for this evolution happening 18 months, even a year. Every year the generations are flipping. So this is all the kind of the stressors on the silicon design, on the topology of the racks, on the testing equipment that is required to keep up with all of these things. And it used to be more along standards, interconnects. And now, again, different companies are trying to differentiate with their own custom solutions for these interconnects. So it's all adding to that complexity that we're talking about.
Great, thank you. I want to turn to networking. I mean, we talked a little bit about networking, and then recently, I was involved with a company called Infabrica, which was bought recently by Nvidia, and it was a lot actually to deal both with compute and the networking. Mohamed, can you say a few words about why networking is important and why this move towards new standards is essential?
I'll use an analogy as well here. So, non-engineering analogy. So, imagine I want to move a lot of, let's say, furniture. I'm moving these days, so I want to move my furniture from place A to place B, right? Easiest way is to pack it all in a truck and just ship it, okay? But I have a lot of furniture, and I shopped around. They don't have a big truck, so what is the alternative? Well, I'll split it into a smaller shipment, okay? But I have one constraint. I want all my furniture to arrive at the same time, okay? So think about GPUs and AI factories similarly, but they're shipping data. They're moving data around in the data center, not furniture, okay? So how do we solve this problem? So we can make bigger trucks, so that it can fit a lot more. So this is what scale up is, much bigger trucks, okay? But then, there is a physical limitation of how big a truck can be, because a bigger truck means more wheelers, means more stress on the highway, means wider highways, okay? So let's say that we solve this problem, we can keep creating bigger trucks, it will reach a limit. Then we need to have scale out, multiple trucks, but they can coordinate together in order to reach at the same time, right? So this highway is the networking, So how wide can I make my highway is the limit of how big of a truck I can make, okay? And the wider and more solid it is, I can move more trucks at the same time without the concrete to collapse, right? So from networking point of view, that the networking here is the key bottleneck for scale, both up and out, actually. Like either if I want a big truck or I want more trucks. So, and this is why we see a lot of like innovation in networking specifically, or we will see even more. It's like photonics and all these connections and all this kind of stuff. So, and even Nvidia has like, you know, Mellanox and all these companies, right? So, yeah.
Yeah. Great example. And then you reminded me, Mohamed, like 2 GTC events ago. So GTC is a big event that happened actually just a few days ago. Nvidia is a big player. And actually Jensen Huang was hosting an event and he used a very similar analogy. And he said, look, I know, 10 years ago, all we had was researchers, so we could talk, bits and bytes, et cetera, but I want to make it very simple for you. What we're trying to do is, if you're a family, we want to eat at home, but my wife wants to eat Thai food, I want to eat Chinese, my kids want to eat Italian, and then we go Uber Eats, DoorDash, and the next thing, these things arrive at different times, and we're not enjoying a dinner together. What we're trying to do, with the scale up, scale out, and scale across, is to bring it all so we can all have dinner together, and we have the Thai food, the Indian, the Italian food, and the Chinese food at the same time. Very similar now. Oh, sure, yeah, and my analogy would be to have the analogy with the. This is part of what's being done because the traffic is becoming very, very differentiated. One person is using ChatGPT to optimize their portfolio. Another person is doing a video and discussing how through AI to identify some key patterns. This is where this is moving to, and then again, this is where a lot of innovation, but also standardization is happening. Very quickly, Hani, on standardization, does that help multi-lane? Obviously, because it creates more opportunities, but it also I see it challenging you because now you have to adopt knowledge and then test the different set of configuration. Is it an opportunity or a huge challenge?
For now, it's an opportunity, but it also comes with its own, costs. Standardization is kind of the insurance policy which ensures that all the different components in the industry that come together to make a network mesh together seamlessly. There are standards towards the dimensions of these connectors. There are standards towards the protocols to ensure that chips from different vendors can communicate with each other. So standardization has kind of been the bellwether which brings us from one generation to another for everything from a compute form factor to interconnect. But today we are seeing a sort of disruption towards standardization. Typically a standards publication takes around 3 years to finalize in the IEEE. But wait, we just talked about everything in the data center refreshing itself every year and a half. So how do these things add up to each other? We are entering a free-for-all. Different companies are leveraging the capital and the momentum and the talent attention to kind of bet on a bunch of different types of products in terms of how to communicate at the application level for transport protocol, the shape and the form of a connector which has to plug into a GPU or a server. So standardization actually does help multi-lane because it allows us to make a certain product or a test tool that a bunch of different companies are going to need. But you have to balance that with agility and nimbleness and time to market because we have to capture this window where all the capital is fresh and accelerate that capital expense into a tangible ROI to make AI more profitable for companies like these guys. And we're not going to get there just by standardizing. So there's a balance of using the standards playbook with taking calculated risks to build new technologies that are driven by cloud customers. So it's a balancing act between the two, I would say.
Thank you. We have a bit of time to do things, obviously turn to questions, but, given that we're focused very much on the MENA and the earlier panel talked a lot about how to educate people and how to leverage them. I want to touch a little bit on this, and I want to start first with Jumana, who has shared with us some very interesting example of how I think Synopsys and other companies have built, education as an integral part in the region, and then how they leveraged it. So, Jumana, if you could start with this, and then others could continue.
Yeah, I mean, we've been talking about all the complexities and the engineering problems that we need to solve, and one of the fundamental components of that is human capital. You cannot solve these problems without talent, without engineering resources. And constantly there is a challenge to find the critical mass of engineering resources with the right education and background and training. So at Synopsys, we've really employed a strategy where we always are looking for a talent pipeline that's associated with academic institutions, universities. That's the only way to be able to create a continuous funnel and a continuous pipeline. And we started out in Armenia, actually, where we built what we call the Synopsys Armenia University, which is a program in which in Armenia at the universities there, the students go through the first 2 years of their degree with the basic fundamental building foundational courses offered by the university. But then the next 2 years is actually a curriculum that's offered and taught, developed, offered and taught by Synopsys employees. And by doing that, we ensure that we're getting a pipeline of talent that's not only academically strong, but actually trained to the skill sets that are directly employable by us or by others in the industry. So that was kind of the first pilot, and was very successful, and we've been doing it for many years. We have now about 1,200 engineers in Armenia working for Synopsys. But then we used that model to actually build similar cases in Egypt, in Jordan, and now in Lebanon. We've started that, and so it is possible, and we have amazing talent in the region that can be tapped into. It's been very successful. And with Lebanon, we started out by putting programs, training the trainers first at AUB and LAU, and so that we can transfer that knowledge of the curriculum to the professors at AUB to teach it through the courses that are offered at the School of Engineering. And then we've done a very directed intensive training program last year to create talent for a specific need that we have, and we're working with a company local in Lebanon to starting a program with engineers over there.
Thank you. That's a wonderful example. Thank you, Jumana, for sharing again. I want to turn first to Hani and then maybe to Wael. But Hani, you live it every day, or your father lives it every day, in terms of identifying and then recruiting talent. If you give us a sense of what could we do more of or better to get this talent?
No, I appreciate the question. So what MultiLane, of course, is a success story for Lebanon, but the challenges that we've had to wrestle and continue to wrestle on a daily basis, are stranger than fiction, frankly. And you need to create an ecosystem that can allow the sort of high-density engineering innovation tapping into a global market. How do we make that scale? We have a four-pillar policy. The first is legislative reform. We need to pass certain laws which enable free economic zones in Lebanon to offer incentive from an infrastructure and cost perspective for more companies to be able to set up in Lebanon. That's number one. Number two is ecosystem development, strategic investments in the form of developing PCB fab houses, developing mechanical components developing automation components in Lebanon, which will allow us to be more vertically integrated and have less dependence on China, which is essential. Number 3 is manufacturing capacity, developing as much homegrown manufacturing, leveraging Lebanon's low cost of labor and high diversity in talent spread all across the country to be able to create high volume, blue collar jobs, which would also help get momentum. And finally, it comes down to talent. We have a strong diaspora. It is both our greatest blessing and a potential serious risk for Lebanon's future. We've all had to leave to be successful, or at least the majority of us have. So that means that we have to develop the talent pipeline, leveraging resources in education and training to get a lot of the next generation involved in this sort of infrastructure play. But finally, and I speak directly to the folks in this room, the diaspora still have the biggest responsibility and the biggest impact towards this vision. Moving to Lebanon and operating out of Lebanon isn't meant to be a logical decision. It's meant to be an emotional decision. And when you feel that emotion calling you home, the first step is to lean into that and take that step, because that's what we did, and that's what everybody else can do, we believe.
Thank you. Thank you very much, Hani. I'm sensitive to time, but I was told by Walid we could get a little bit more. Yeah, I want to turn obviously to the audience, but Wael or Mohamed, can you add a little bit more to this comment about talent and
just a small comment, because I just wanted to make sure that we leave with a positive thing, which is there's obviously a lot of talent here. There's a very strong, I think, kind of potential inside the country. We know that. The good thing about a lot of what's happening here is, the standardization is one thing. There's also a lot of openness. There is an open standard, open compute organization that is actually opening up a lot of the tech to adoption. Obviously, it doesn't make them cheap, but it at least makes them available to folks who wanna do something there. So there is obviously, as everybody's mentioning, government interest is needed, but I think with that we can definitely build something. As complicated as it looks, I think we have the people. I mean, day to day I interact with a lot of people from Lebanon in key places with key knowledge and expertise. A lot of people from the Arab countries. There's definitely room from a human perspective to do something.
And it's never been more possible than now.
Right.
With all the connectivity of the world.
He wants to ask a question? Oh, okay, sure. No, I'm okay. Any other comments? I want to turn otherwise to the audience if there are specific questions. Go, yeah, right there.
Just one question.
Yeah, sure.
Hello, thank you for the panel. So my name is Karim Zarzour. I'm a software engineer. My question is about data center security, in the sense that we saw in this age of AI warfare, data centers have become targets. And we saw an incident a couple of weeks ago, AWS in Dubai, they had a data center go down. We know as software engineers, to mitigate this, we deploy to multiple geographical regions, and then we fall back and reroute traffic. But what are your thoughts on this in terms of, are we going to start having, security domes around data centers? Will we have to move them to areas underground or in where they are less threatened by any attacks, let's say?
Space.
Right.
Mohamed, you want to answer this one quickly? Wael?
There are definitely a lot of different kinds of risks and security challenges. Putting aside the kind of the war-based ones, just from securing the data, securing access to the data center, this is an ongoing and will never-ending fight. I think there are strong initiatives in the general data center community to put certain hygiene into building systems from the hardware perspective already, and also building the software around, especially for AI, where you get a lot of data. Once we get to the point where we have shared data centers, we have data from different sources or different clients or customers. Today, as it is, there's little sharing of infrastructure, but going forward, it's going to start happening, and there's quite a lot of work on that. But again, I think it's a never-ending struggle that will keep fighting.
Okay.
Thank you.
Thank you.
Great.
Thank
Thank
you
you very much.
everyone. Thank you.